Ever wondered why there's so much talk about energy crisis? Well, as our societies continue to grow and develop, so too does our need for energy. The ways we've been meeting these needs, primarily through fossil fuels, are not without their problems. They're finite resources, for one, and their use contributes significantly to environmental degradation. So, where do we turn? Enter nuclear fusion, a process that powers the sun and the stars. Could the answer to our energy crisis lie in the heart of stars through a process called nuclear fusion? Nuclear fusion sounds complicated, right? Not really when you break it down. Let's dive in. Picture this: two light atomic nuclei coming together in a cosmic dance, merging to form a single, heavier nucleus. This process is known as nuclear fusion, and it's not just a fancy science term. It's the very mechanism that powers our sun and other stars. It's the universe's method of creating energy, and it's incredibly efficient. Now, you might be thinking, isn't that the same as nuclear fission? Well, not quite. While both processes involve atomic nuclei and release vast amounts of energy, the way they do it is quite different. In nuclear fission, a heavy nucleus is split into two, releasing energy in the process. It's kind of like breaking a large rock into smaller pieces. On the other hand, nuclear fusion is more like building a sandcastle. You take two smaller grains, or light atomic nuclei, and combine them to form a more massive castle, or a heavier nucleus. And just like the satisfaction you feel when you finish that sandcastle, the universe rewards this fusion process with a burst of energy. But it's not just any energy. It's a colossal amount, millions of times more potent than burning coal or gas. But remember, this isn't a process that happens easily here on Earth. It requires incredibly high temperatures and pressures, conditions similar to the heart of a star. In fact, it's so extreme that it's been dubbed creating a star in a laboratory. But why go through all this trouble, you might ask? Well, because nuclear fusion has the potential to revolutionize the way we generate power. It's a clean, virtually unlimited source of energy that could replace fossil fuels and reduce the impact of climate change. So, in essence, nuclear fusion is like creating a star here on Earth. Sounds exciting? Wait till you hear about the benefits. Imagine an energy source that is clean, safe, and virtually limitless. That's nuclear fusion for you. Now let's delve into the key benefits of nuclear fusion. First off, it's a powerhouse. The fuel for fusion is found in seawater and lithium, both of which are abundantly available on Earth. This means that nuclear fusion could provide a nearly inexhaustible supply of energy. Just think about that for a moment. An energy source that could keep the lights on indefinitely, without the need for constant fuel mining or drilling. Next up, let's talk about the environment. Unlike traditional nuclear power, fusion doesn't produce long-lived radioactive waste, and it doesn't contribute to climate change. This means that nuclear fusion has minimal environmental impact. It's a green energy source that's truly green. Lastly, let's discuss safety. Now, we all know the horror stories associated with nuclear power. Chernobyl, Fukushima, the list goes on. But here's the thing, nuclear fusion is fundamentally different from nuclear fission. In fusion, there's no risk of a chain reaction that can lead to a meltdown. It's like comparing apples and oranges. They're both fruit, but they're not the same thing. Now, you may be wondering, if nuclear fusion is so great, why aren't we using it already? Harnessing the power of a star is no easy task, and that's where the challenges lie. Indeed, the technical hurdles are formidable. To achieve nuclear fusion, we need to reach and maintain incredibly high temperatures, some millions of degrees hotter than the core of the sun. Simultaneously, we must sustain immense pressures akin to those found deep within gas giants. But let's not be disheartened. The future is brighter than it seems. Researchers around the globe are ceaselessly innovating, striving to overcome these obstacles. They're developing advanced materials to withstand extreme conditions and exploring ingenious methods to control and contain the fusion reaction. These scientific pursuits are inching us closer to a breakthrough. So while the pathway to nuclear fusion is steep, the climb is not in vain. Advancements in science and technology are propelling us forward towards the cusp of a revolution. While nuclear fusion may not be here just yet, it holds the promise of a brighter, cleaner and more sustainable energy future.